The first thing that you want to do when you solve a rational inequality is to put it in this form, where 0 is on one side of the inequality and a single fraction, where both the numerator and denominator are in factored form, are on the other side. Okay, what we're going to do is classify everywhere where this is positive, negative, 0, and undefined. We start by finding the zeros of the numerator and the denominator. Okay, so x plus 1 is equal to 0 if x is negative 1, and x minus 2 is equal to 0 if x is 2. X plus 5 is equal to 0 if x is negative 5. So what we do is put all of these three values on a number line to classify this function right here. Okay, above negative 1, I'm going to put 0 because that's where the function is 0. Okay, the only way that a fraction can be 0 is if the numerator is 0. So this fraction is 0 when x is negative 1 and when x is 2. This fraction is undefined if the denominator is 0, because we can't divide by 0. Okay, we get an undefined value. So negative 5 is where the function is undefined, so I put a u there to denote that it's undefined there. Now, similar to polynomial inequalities, we're going to choose test values in each of these remaining pieces and find out where the function is positive and negative. So something less than negative 5 is negative 6. Between negative 5 and negative 1, negative 2. Between negative 1 and 2, 0. And something greater than 2 is 3. So we take each of these test values and plug them into the function to see if it's positive or negative there. So if we plug in negative 6, we get negative 6 plus 1, which is negative 5. Negative 6 minus 2 is negative 8. And then negative 6 minus 5 is negative 1. So we get positive 40 divided by negative 1, and that's a negative number. Okay, similar for x equals negative 2. Negative 2 plus 1 is negative 1. Negative 2 minus 2 is negative 4. And negative 2 plus 5 is 3. So we have a negative times a negative divided by a positive. So negative times negative is positive, divided by positive is positive. When x is 0, we have 0 plus 1, which is 1. 0 minus 2 is negative 2. 0 plus 5 is 5. So the net of this is a negative number. Finally, when x is 3, we have 3 plus 1, which is 4, times 3 minus 2, which is 1, divided by 3 plus 5, which is 8. So we have a positive times a positive divided by a positive, so the net is positive. Okay, so greater than or equal to 0 means either positive or equal to 0. So we want to find out where this is positive and where it's equal to 0. Okay, it's positive between negative 5 and negative 1, and it's 0 at negative 1. So we write that as open negative 5, comma, negative 1. And we include negative 1 because it's allowed to be equal to 0. We don't include negative 5 because the function is undefined there. So it's everything between negative 5 and negative 1, it's positive, and at negative 1, it's 0. And then moving along, we find out that it's 0 at 2, so 2 is included. And everything above 2, the function is positive there, so 2 all the way to infinity. Okay, so positive from this to this, and positive from this to infinity, 0 at negative 1 and 2. So this is the solution to the inequality. Okay, let me give you one to try. Okay, press pause while you work on this one. Okay, so your number line should have looked like this. So the zeros are at negative 3 and negative 2, and the undefined points are at 1 and 5. Okay, and you should have gotten positive, then negative, positive, negative, positive. So finally, we're looking for where this is less than 0, strictly less than 0 is strictly less than 0 between -3 and -2, and on this interval here, which is from 1 to 5. So this right here is the solution to this rational inequality.